Hello everyone. In this session, let us understand the concept of tree map. Tree map is again similar to the concept of hash map that we saw in the previous session. We can add the values or data in the form of key and value inside the tree map as well. But there are some differences, like the tree map is implemented on the basis of a red-black tree structure, and the entries in the tree map, they are sorted by default by using keys. The entries from the tree map, they are sorted. It is guaranteed that whatever entries we add to a tree map, they are sorted by default in the ascending order of the keys, which is not guaranteed in case of hash map. That's the biggest difference. In the hash map, when we add entries, it is not guaranteed that the values are sorted or keys are sorted. But in case of tree map, yes, it is guaranteed. Apart from that, there are some methods which are common in between the tree map and the hash map. These are the common methods, out of which most of them we have already seen in the previous session. Put method, get method, contains key, contains value. We haven't seen in the previous session, but yes, it works with the hash map as well. So contains value is used to check whether a particular value is present in the tree map or hash map. And the replace method is also like put method, which also we will see in this session, and other methods like remove, clear, key set, values, entry set is same. So we are not going to see them again in this session, but we'll take a look at contains value and replace method. And of course there are some methods which are unique to the tree map, like getting the first entry, getting the last entry, first key, last key, and some poll methods. Those also we'll see in this session. Okay, so first things first, I have created an object of tree map, and this map holds the keys of characters and values of integer, and also I have added some values like D, 1000, 8, 2000, etc. So first let us see how it displays in the output. Like I said, the entries are sorted using keys by default. So when we try to take a look at the output, we can see that the entries are automatically sorted by using the keys. Okay, and then let's take a look at this contains value method. So as the name indicates, contains value will help us checking whether a particular value is present in the map or it is not present in the map. It is fine with both hash map and tree map. It works with both. So yes, this particular value is present. If it is not present, obviously it is going to say false. Okay, apart from that, there is another method, replace, which we didn't see for hash map, which we'll see it here. So in the previous session we saw that to replace an existing value, what we do, we just can use put also. Like for example, if I want to change the value at A to something new, instead of 1000, I want to change it to say 6000. So put will also work as replace. Put will also work as replace in this case. And when we take a look at the output, it will display the value of A as 6000. Apart from that, you can also use replace in this case. If you use replace, it will work the same. It will replace the current value of 1000 to the new value, or current value of 2000 to the new value of 6000 in this case. So they are one and the same. So over here, the value of A is changed to 6000. Other than that, other methods, getting the value and removing, or getting the key set, value set, entry set, they will work exactly the same way it works for hash map. Now let's take a look at these new methods. What is this first entry, last entry? So tree map supports some methods to get the values quickly. Like I want to get the first entry of the map, getting the last entry of the map, getting the first key, last key of the map. Let's take a look at these methods one by one. For now, let me comment these lines. So when we do map dot first entry, it is going to give me, of course, the first entry. And when we do map dot last entry, it's going to get us the last entry, that is this one in this case. So remember that when we add the values, they are sorted in the ascending order of the keys. So first entry will be this one, A 6000, or 2000 because we have commented the replace, and the last entry will be D 1000. So last entry won't be like B 4000 and first entry won't be D when we get these values, it will be sorted. So after sorting, whatever is the first entry, whatever is the last entry, whatever is the first key or last key is what we are going to get here. So first key and the last key. So when we run this program, we get the first entry as 2000, the last entry as 1000, and A is the first key and B is the last key, as simple as that. And also, interestingly, there are two more methods, that is poll first entry and poll last entry. So this will give you the first entry and remove it also. It's very interesting. It will give you the first entry, it will return the first entry, and it will remove it. If you do something like map dot poll first entry and run the program, so it's going to give you the first entry, that is A 2000, and then it is also removed from the map. So this is interesting to note. And similarly, when you do something like map dot poll last entry, it is retrieved, the last entry is retrieved and removed also. So in this case now there is no last entry present in the map. Okay, so when we want to get an entry and also remove it at the same time, these methods are useful, poll first or poll last. This is about the tree map. Very easy but very important. Thank you so much for watching this video.